Hello. So this is another topic in 20 video, the key bits of weather hazards. One of the more sort of complex topics in geography, but if you take your time through it, there is no reason why it can't be as straightforward as any of the other topics. I'm going to try and stick to 20 minutes on this one, but it's quite a chunky topic in 20, this one. So just remember, this is the key elements of a topic in around 20 minutes, just to sort of help you out a little bit. So here we go. Now, the first thing to understand with this weather topic is just the notion of pressures. Now, what you want to think about it is high pressure is like something is squeezing the air down towards the ground, and what that means is that water vapor cannot rise, or it struggles to rise. So you don't get much condensation, and the result is you get clear skies and calm weather. The opposite to that is low pressure, where you've got that less dense air rising up, okay, resulting in water vapor rising as well, leading to condensation and cloudy skies with stormy, rain-based weather. So basically, if you see clouds, you've probably got an area of low pressure. But just understand, high is sinking and low is rising air. So you've kind of got to understand that before you can move through this topic. Now, you've got to also be familiar with the global atmospheric circulation model. Usually in your assessments, you'll be given a little bit of guidance on this, but generally it's divided into three cells: the Hadley, the Ferrel, and the Polar. And you can see here at the equator, you've got the rising warm air of the Hadley cell, which then cools as it moves northwards, and then it sinks over that area of high pressure, over around 30 degrees north and south. What that means is that in these areas, you've got deserts, both hot and cold, because there is sinking air, so there's no water vapor able to rise up and cause weather. In the middle area, if we're looking at Africa particularly, you get the savanna or tropical grassland, so a little bit more rain, so you get a little bit more vegetation and life. And then sitting on that equatorial band, you've got the rainforests with lots of rising air, lots of condensation and rainfall. This is not the video for a full explanation of the GAC, but you've just got to understand the kind of the basics of it. The Ferrel cell, if you look, moves in different ways. So here the wind is moving north, here the wind is moving north, but here, look, the wind is actually moving in a southerly direction. So the Ferrel cell acts in a slightly different way. The way I remember this, feral often means you do not act in the proper way. You're feral. It's the same with the Ferrel cell. It does not act in the same way as the Polar and the Hadley cell. One key point with this to bear in mind, there are no winds or very low winds over the equator. Okay. Leads to something called the Doldrums. Tropical storms do not form on the equator, they form around it. We'll have a look at that later. On the subject of tropical storms, you need to be aware of their formation. So we can see here a classic hurricane forming in the Gulf of Mexico with that area of high pressure in the eye, very clearly noticeable there, and you can see the tailwinds of the hurricane rotating around that eye there. These really are the monsters of weather. They are incredibly damaging, these weather hazards. For them to form, I guess, luckily, you need four main things, and this is what keeps us safe from them. So, before I do go over that, you can see here, hurricanes do form around this tropical area where it is warmer. They do not form over the equator because there is low wind over the equator, so they do not form. Hurricanes Cyclones, typhoons are all the same thing. They are all basically super fast tropical storms. They're also known in Australia as Willy Willies, which is just a fantastic piece of AO1. And as you can see, the winds tend to move from east to west with the trade winds. So the trade winds are the strongest winds that blow around the equator, okay, and they form in the Hadley cell, and these storms move with it. Now, you need 4 main ingredients for a hurricane, typhoon, cyclone. First, it needs to be within the tropics. So it will be within that tropical zone where the ocean temperature is really nice and warm, so more than 27 degrees Celsius, just so the storm has got that thermal energy to begin feeding off. Your water needs to be more than 60 meters deep, and you also need something called low wind shear. So wind shear is basically the changing direction of the wind. If you've got high wind shear, the wind is changing direction lots. And what this can do is rip apart any sort of cumulonimbus storm cloud. So it will rip apart the cloud and then you can't get your tropical storm. So you need low wind shear so as not to tear apart the clouds. Those are your ingredients. You need to be quite confident with those, but nothing more than this really. Now, when it comes to hurricanes, you will often be asked how they form. This is probably where it gets most technical in this topic. Just have a little look at this. Pause if you need to. So what we can see here is the process model, firstly, secondly, third, fourth, and finally. This is not kind of like a hard and fast rule. You might only have firstly, secondly, thirdly. You might have a fifth and then a finally. It's just as long as you're following that process. Now, there is more to it than this, but the basic sort of introduction to it is you've got that warm rising air in an area of low pressure in the tropics with 27 degree water, with 60 meter deep water, with low wind shear. As that warm air rises and that water vapor rises, you get condensation. And that condensation actually creates a type of heat called latent heat. That process happening on a large scale will lead to a tropical storm. The Coriolis effect, so the spin of the Earth, the anti-clockwise spin of the Earth, will cause the winds to spin around an eye, which is an area of high pressure. The storm will form a rain bands, so basically just like layers of rain clouds, and it will move with those trade winds. And when the speed reaches 74 miles per hour, it will become a hurricane, a cyclone, a typhoon, whatever you want to call it. 74 mile an hour is that golden zone when it is officially classed as a hurricane. When the hurricane moves over land, it will begin to lose energy because it will not be over that warm ocean anymore. Okay, so a hurricane gathers all its energy from it gathers most of its energy from the warmth of the sea and that latent heat from condensation. So if you take away the sea, you remove that source of heat. Also the depth of the ocean as well. Here we can see just a general structure of a hurricane. You can see the eye there, the area of sinking high pressure, which leads to calm weather in the eye. Low rain, low winds. You can see these bands here of rain, which will bring with them gale force winds, torrential rain, really damaging weather patterns. Here you go, you can see here, rotating counterclockwise with the Coriolis effect and moving with those trade winds. Case study for your weather topic is Typhoon Haiyan. Okay, a super typhoon, a category 5, the worst you can get. Now remember, you could call it Hurricane Haiyan. They're the same thing, but in this area of the world, they're referred to as typhoons. Have a little look at the map here. As you can see, it affected the country of the Philippines, a poor-ish country in Southeast Asia, an archipelago, which means a group of islands very at risk from natural hazards such as typhoons. 170 mile an hour winds, a storm surge, so like a wave of water created by the hurricane or the typhoon of 5 meters high. It really was a monster. And this city here, Tacloban, was one of the largest cities right in the track of this typhoon. It caused untold damage to this city. To look at that damage, just remember, a primary is an impact that happens directly as a result of the disaster. So, for example, death, injury, destruction, and homelessness, because homes are destroyed and you become homeless immediately. Secondary, I should say, is an impact that happens as a result of the primary. So, for example, disease, service stress, civil unrest. You will often be asked in your exams to compare these and come out with what's worst. If we have a little look, you can see some of them here. Now, it's really important here at times to bear in mind that little bit of extra AO1. The Philippines is a fishing nation. I mean, why wouldn't it be? It's an archipelago, it's a group of islands. But fishing is one of the main sectors of employment. The poorer people of the Philippines will often have a fishing boat that will have been passed down through generations, and it provides a job with food, income for these people. 30,000 fishing boats destroyed is an immense amount of damage, but then also bear in mind the amount of families that have been damaged by this, who have lost their ways of life, their means of making money. Just that knowledge that the Philippines is a fishing nation is that little bit of extra AO1. It goes a long, long way. Yeah, so just bear that in mind. Now, the responses, just as important, and you've got to be, again, aware of these. So an immediate response is something that is quick, and it is designed to alleviate, which means like lessen immediate suffering. So search and rescue, tents, emergency resources. Long term is a response that develops the area over time, such as improving buildings to make them better, roads and hospitals. Something you've got to bear in mind is these areas that are affected by hazards, they're not one-off occasions. The Philippines sits in the hurricane, typhoon, cyclone zone. They will always have them. Italy, for example, sits on a destructive plate margin. They will always have earthquakes and volcanoes. So long-term responses are very, very important because they know they will have these hazards again. These things will keep happening. So they have to be prepared to meet these challenges in the future. Here you can see some of those immediate and long-term responses. Now, the rebuilding of roads, bridges, and airport facilities were very important in the long term, as Tacloban Airport was a main access point for people, for aid, and that will be the same in the future as well. Cyclone shelters were built, curved fronts with flat roofs, so they lower wind resistance, built on stilts, to guard against storm surges. Now, these shelters are very, very expensive. They were not built for every family. They were often built as, say, community centres where people could evacuate to if they needed. Little bit of extra AO1 here, really, really useful. When the USA sent their aircraft carrier, they did not just send the carrier. These ships move in something called a strike group, where it will move with lots of different ships, including hospital ships. And these strike groups are filled with trained individuals, equipment, aeroplanes, helicopters, drones, ships, but they also come with the logistical capability of the US military. They were able to organise and rescue people effectively. This little bit of extra AO1 goes a really, really long way. So these little bits of knowledge can really help you to unlock that higher level of understanding and knowledge. It really does go a long way. Now, you have to be aware of ways to reduce the risk from not only earthquakes and volcanoes, but also from hurricanes. AQA use this language on the left-hand side, so you've got to be familiar with it. You can monitor, which means to look out for a hazard. Now, you might do this using satellites, radio zones on the bottom of weather balloons, and buoys. A buoy can measure for a rise in sea level, for example, indicating if there's a storm surge coming, or when low pressure is causing air to rise, it will literally allow the sea to rise a little bit, resulting in that buoy detecting it. Prediction follows a similar idea, but you use data from historical events. This is important for hurricanes because there is a hurricane season when the sea is warmer than what it would be at the rest of the year. So you can generally predict when they're going to happen. Protection, which is where you make infrastructure more resistant to the hazard. So better built airports, stronger roads, bridges that can survive the winds, buildings that can sway with the wind, all very important. Also the storm shelters. And planning, just making sure people are ready. You've got early warning systems, you've got emergency drills, you've got shelter kits, you've got everything you need to make sure people are ready for the disaster. Now, you also need to be aware of a HIC or a British weather event. And for us, it's the Beast from the East. Or, for that little bit of extra AO1, it was actually called Anticyclone Hartmut. Now, this happened in 2018, you may remember it, and it brought massive levels of snow, cold weather, icy conditions. Now, not only did we suffer from Anticyclone Hartmut, or the Beast from the East, we also had Storm Emma blowing in from the southwest. So we had two quite significant weather events happening concurrently. Oh, you can call it Beast from the East, that's fine. If you call it the Beast from the East, you will get the mark, that's no problem. Anticyclone Hartmut is just that little bit of extra nice AO1 that shows you've researched it. Here are some of the effects. Now, something you've also got to be confident with is the notion of social. So it impacts to do with people, economic, which involve money, and environmental, which involves either the natural or the built environment, which people tend to forget. So 10 reported deaths, social, water pipes bursting, you could say economic because it costs money to fix. We were worried that the UK could run out of gas. Well, that's economic because it's going to have to pay for it. Maybe you have to pay for more gas from abroad, or social because people won't be able to heat their homes. 125 schools were closed in North Yorkshire. Social, these children obviously missed out on education, but economic, parents had to stay at home Self-employed parents may not have been able to go to work, so they lost money. Damaged crops, farmers lost money and lost yield. Increased coal and gas use to keep people warm, causing environmental issues. Destroyed habitats, animals suffered complete ecological breakdown because of this. Now, with social, economic, and environmental, if you can justify what you think, then you're looking okay. So if you can justify that 125 schools closing in North Yorkshire is an environmental concern, if you can give a full, reasoned argument for it, then fair dues. So it's all about being able to justify it. But stick with what you know. This is clearly social. Okay. That is about it. So that was your topic in 20 for weather hazards. Just remember, this is no substitution for your own revision. Okay, there's a lot more to it than this, but this is just me taking you through those core aspects of the topic. I hope this helped, and please come and find me if you need anything. All right, guys, I'll see you later. Take care.